All right, welcome to the EtherChannel slideshow for CET236. So, I do highly advise watching the Jeremy's IT Lab EtherChannel video. You don't necessarily have to if you're feeling pretty confident with EtherChannel and the ideas behind it. You could just go with the slideshow and do the assignment. However, watching the video from Jeremy's IT Lab will give you a little bit more context into what I am referring to in some of the slides in this slideshow. With that being said, we'll move on. So the EtherChannel takeaways from the video. Spanning tree will block unbundled redundant links between switches to prevent layer 2 broadcast loops. And we saw that with the spanning tree assignment from last week, where if we put redundant links in between switches, then spanning tree would block one of the links to prevent a loop. So as you can see here in the diagram, there's no EtherChannel set up. We just connected 4 links to from multilayer switch 1 to multilayer switch 2. And as you can see, multilayer switch 2 put gigs 102, 103, and 104 in the alternate port role. Therefore, the link here, and here is essentially unusable for the time being, unless for some reason this link were to go down. Then one of these would take over. It would probably be 102 to 102. So that's why we need EtherChannel, because we want to utilize all those links. EtherChannel bundles multiple physical interfaces together to act as a single logical interface. So with EtherChannel configured on the bottom, spanning tree treats the physical bundle as one logical link. So therefore, all the interfaces get used because spanning tree allows it, because it thinks that all these 4 links are just one logical link. When you see links tied together with an oval shape in a diagram, that indicates that the links are bundled together. So just like that, if you ever see a diagram with this oval shape kind of tie-in links together, that indicates that those links are in an EtherChannel. It is best practices to bundle 2, 4, or 8 links together to achieve maximum load balancing efficiency. That's just kind of for your information. So it's not that you can't necessarily try 2, 5, 7, something like that. It's just better for load balancing efficiency to bundle, 2, 4, or 8. The logical or virtual interface that is created during an EtherChannel configuration is also called a port channel. So sometimes EtherChannel and port channel are kind of interchangeable terms. However, when I am talking about port channel, I am going to refer to the actual virtual interface that is created when you bundle physical interfaces together. So the port channel down here at the bottom, you can see it's one logical interface, one logical link with 2 logical interfaces connecting the 2 switches together. So port channel 1 to port channel 1. The port channel virtual interface has a maximum bandwidth equal to the sum of its member link bandwidth. So here we have 4 1 gig links, so 4 gigabit Ethernet links, each with 1 gig of bandwidth. When we combine them all together to one logical link, it's not perfect, but it has the capability of providing a maximum bandwidth of 4 gigabit. So in this case, because we're bundling 4 links together, we do have a maximum throughput of 4 gigabit. The port channel is abbreviated as PO, followed by the interface number, and in this case, PO1 was used. We'll see more on that later. You define the port channel interface number during EtherChannel configuration. So it doesn't have to be PO1. It doesn't have to be PO1 over here. It could be PO2 over here, PO3 over here, PO9 over here, PO27 over here. It doesn't really matter. You define that number. EtherChannel configuration. There are 3 different ways to implement EtherChannel. LACP, this is the most popular one, the most used in production. Link Aggregation Control Protocol. It's an open standard which means it's vendor agnostic. You can use it from a Cisco switch to a Juniper switch, or a Cisco router to a HP router. It's an open standard, so most vendors are going to support it. It dynamically negotiates whether a link should be bundled or not. So if you have, let me go back just a little bit. So like over here, if you have this bundled in LACP, and you have this, let me point up here. If you have these bundled in LACP in a channel group, and you don't have these bundled, then even though this is configured for LACP, it will not form an Ether channel until this is also configured as LACP. So anyway, that's what that means. It dynamically negotiates. We will primarily be using LACP to set up EtherChannel and CET236. Next protocol, PAGP, Port Aggregation Protocol. This is Cisco's very own link aggregation protocol. It only works on Cisco devices. It also dynamically negotiates whether the link should be bundled or not. We will not be using PAGP and CET236, so we're not going to spend too much time on it. Just know that it is a link aggregation protocol. The last one we'll talk about, and this is used, static EtherChannel. It's mostly vendor agnostic. Most vendors will support static EtherChannel. No link negotiation takes place. So if you configure it on one end, it's expecting that the other end is also going to be configured in a static Ether channel, and it will not work unless the other end is also configured in static Ether channel. Whereas LACP, if one end is configured with LACP and the other end is not, then it just won't bundle the links. It will just continue to send it as if the links were not bundled. So link aggregation control protocol and port aggregation protocol will negotiate with the other side to see if the other side matches its settings. However, static Ether channel does not do that. There is no negotiation. If one side is configured as static Ether channel and the other is not, well, your link's not going to work. We will occasionally use static Ether channel in CET236, including in this week's assignment. In the real world, LACP is the dominant method set up in Ether channel, while static Ether channel is sometimes found bundling links between a switch and a server. That's the situation that I see it used in the most. It doesn't mean that you can't use it between a switch and another switch, or a router and another router, or a switch and a router. Like, you can do it. Just LACP and PAGP are superior because they do negotiate. PAGP is not very common, but it still works just as well, but only on Cisco devices. In addition, I don't believe that it's covered on the CCNA exam, so we're not going to spend too much time talking about it or configuring it. Regardless of which method you choose, the initial process to bundle the links is mostly the same. First, you got to determine which interfaces need to be bundled together. And in this example, we are going to bundle all 4 of these interfaces on MLS1. Each interface range configuration mode, enter interface range configuration mode that includes all of the links that you want to bundle together. There we go. We're going to go into configure terminal. Interface range gigabit Ethernet 1/0/1-4. The result of this command takes you to interface range configuration mode. So instead of config-if, now we're in config-if-range. That means you're not just configuring one interface, you're configuring a range of interfaces. And in this case, the range of interfaces ranges from G101 to G104. We are now ready to begin bundling the links into an Ether channel. Syntax for configuring the bundle for Ether channel. Channel group, then the group number, mode, then the Ether channel mode. We'll talk more about that. The group number is an arbitrary number that you determine, and this number does not need to match on both sides of the link. It is only significant or unique to the device that you're configuring. So like I said earlier, on one side you could have port channel 2, and on the other side you can have port channel 27. One side you can have port 7, The other side, you could have port channel 57. It's only unique to the device you're configuring. Cisco devices will typically accept a group number range of 1 through 128, although older Cisco devices and Packet Tracer limits this to 48. So just know that if you try to put something in a channel group, the range of the channel group numbers are going to be 1 to 48 when you're using Packet Tracer. The EtherChannel mode, so this variable, dictates which EtherChannel method will be used for bundling, i.e. LACP, PAGP, static EtherChannel. So what you put here tells the EtherChannel what kind of protocol you're going to use. And the options for the EtherChannel mode variable are active. This tells the bundle to actively try and form an LACP EtherChannel with the other end of the link. Passive instructs the bundle to form an LACP EtherChannel only if the other end is set to active. So before we move on, I would like to say that I don't ever use the passive command here. I typically configure both ends of the link to be in active mode. I would argue that hardly anybody uses active on one end and passive on the other. Most people just use active on one end and active on the other end. Granted, LACP is going to send out information on both ends of the link because they're both set to active, trying to form a LACP EtherChannel link, but that traffic, in my opinion, is pretty minimal. So I don't think it's a big deal to put active on both sides of the link. Moving on. Desirable. This instructs the bundle to actively try and form a PAGP EtherChannel with the other end of the link. So basically the same as active, but for PAGP. Auto instructs the bundle to form a PAGP EtherChannel if the other end of the link is set to desirable. So this is the equivalent of LACP's passive. Okay, so active is the PAGP equivalent of desirable, and passive is the PAGP equivalent to auto. On. This forces the bundle to form a static EtherChannel unconditionally. Okay, and that's it. There's no active, passive, desire, auto. It's just on. It's just on. There's no negotiation, and the other end of the link better be on. It is generally acceptable to use active or desirable on both ends of the link. However, an EtherChannel will not form if you use passive on one end and passive on the other end, or auto on one end and auto on the other end, or any combination of incompatible protocols such as active auto. Remember, active is for LACP, auto is for PAGP. Also desirable passive, so desirable is PAGP, passive is LACP. So if you try to put one end of the link as PAGP and the other end of the link as LACP, that will not work. Or if you have on one side of the, or static EtherChannel on one side of the link and active LACP on the other side of the link, that will not work either. LACP EtherChannel configuration. Tying the last several slides together, here's an example of how to configure LACP EtherChannel using the diagram below between MLS1 and MLS2. Remember, as we started off, if there's no EtherChannel, spanning tree is going to block 3 out of the 4. Only one of these links will be active without EtherChannel bundling. So on MLS1, configure terminal. Interface range gig 101 to 4. Channel group 1 mode active. So what is that going to do? So channel group 1, this tells us we're going to create a port channel interface called port channel 1. Mode active. This active keyword right here tells us that we are going to form an LACP EtherChannel in that bundle. As soon as we hit this command, submit this command, it says right here, creating a port channel interface called port channel 1. So now we've got that virtual port channel interface. Spanning tree protocol starts reconverging because now instead of 4 links, now this switch thinks it just has one logical link. Okay. Same thing on MLS2. Config terminal. Interface range gig 101 to 4. Channel group 1 mode active. So we just told MLS2 to do the same thing. Spanning tree starts reconverging for it because now MLS2 has one logical interface. And a few moments later, we have an EtherChannel bundle. Look, all of the ports are forwarding because this is an EtherChannel bundle and we have one logical 4 gigabit Ethernet link. Okay? Each connected on the virtual interface of port channel 1, port channel 1. So if you're physically looking at the switches, like with your eyes, you will see 4 physical links, but the switches interpret that bundle as one logical link. And Spanning Tree's happy with a single link, right? It doesn't like 4 links, but it's happy with a single link. So that's why all of these ports are forwarding, because they're all part of a virtual interface. Configuring the port channel interface. So now that we have our physical interfaces bundled into a single logical interface, aka the port channel, we can configure the port channel interface just like we would any other interface. So, configure terminal. Interface, port channel 1. Now, so remember, going back, right here, as soon as we entered this command, group 1 mode active, you get a little message that pops up, says creating a port channel interface called port channel 1. Okay, now we have that virtual interface. All right. So we're going to go into interface configuration mode, specifically into interface port channel 1. So this is just like entering configuration mode, just like you would enter it for gig 01 or gig 111 or whatever. But we're just entering interface configuration mode for the virtual interface port channel 1. Next command, you all know this, switch port mode trunk. Switch port trunk native VLAN 777. That's the typical native VLAN that we've been using in our past labs. Doesn't mean you have to set it to VLAN 777. That's just kind of the number that I choose quite often. And arbitrary VLAN, well, not arbitrary, but this is just an example of switch port trunk allowed VLAN 10, 20, 30, 40, 50, 99. That's the trunk allowed command that we used in the last assignment with DHCP and DNS, I believe, and SSH. So you configure this interface just like you would any other interface connecting to another switch. Okay, same thing, except we're putting it on this virtual interface right here. Same thing with MLS2. We go into interface configuration mode, port channel 1, configure all these trunk commands. Okay, no sweat. You guys have been doing this for a long time. Easy. Verifying the port channel interface. Make note of the interface configuration of either switch by issuing the show running config command or just show run. And I cut out a lot of the information that's not pertinent to this slide, but if I went down a little bit into the running configuration and snipped this little bit of information here. At the top, you can see where we have interface port channel 1 and everything that's configured for it. So physical interfaces, G01, G02, 3, 4, were manually configured to join the channel group 1 using LACP. And we see that with the commands that are highlighted in blue. Each one of those interfaces belong to channel group 1, and its mode is active. And just by looking over here, without me telling you, you can tell me that these are bundled for LACP because of this active mode. Okay? If that said desirable, you know it's what? PAGP. If it said on, you know that that's static ether channel. However, it says active, so you know we're using LACP. Interface port channel 1 has the configuration that we manually applied. Look, we manually entered these in. We told it to have a switch port trunk native VLAN of 777. We told it to allow VLAN 10, 20, 30, 40, 50, 99. And we told it to be in trunk mode. Okay, not necessarily in those order, but that's the order that the running config shows it. Physical interfaces G0, 1, 2, 3, and 4 had the same configuration automatically applied to them that we manually configured on port channel 1. So we manually put these on these three commands on port channel 1, but look what the switch did. It automatically applied that to each physical interface. Okay, just keep that in mind. So if you ever looked at the running configuration and said, hey, I never put anything on gig 101 except for telling it to be in the channel group 1, well, when you put it on the port channel, it automatically puts it on the physical interface. Okay, that's why all of these look the same. And they should be the same, by the way. All right, recap of LACP configuration. From start to finish of this demonstration, here are the commands that we issued. Conft interface range gig 101 to 4, channel group 1 mode active, interface port channel 1, now we're in port channel 1's configuration, switchboard mode trunk, switchboard trunk native VLAN 777, switchboard trunk allowed VLAN 10, 20, 30, 40, 50, 99. That's it. That's all we did. And for PAGP, it's exactly the same as LACP with the exception of the EtherChannel mode. So look right here. That's the only difference. LACP, we've got active. PAGP, we have desirable. Static EtherChannel, we have on. PAGP, LACP, PAGP, static EtherChannel. Okay. Side note though, however, packet tracer routers only accept static EtherChannel, but modern routers will work with LACP and PAGP. I think at some point, hopefully they will put it in the software coding of packet tracer to allow Cisco routers in there to accept LACP. Also keep in mind, please, that I will be showing you in the next video that the syntax on a Cisco router is a little bit different for this command right here, where I'm hovering my mouse. Okay, because Cisco routers and packet tracer only accept static EtherChannel, you don't need to type this mode on. Okay, because it only accepts static EtherChannel, you just have to say channel group, group number, channel group 1, channel group 7, whatever. As soon as you type in the channel group and then the number, it puts it in static EtherChannel. You don't have to type the mode on. Okay, that's only for Cisco routers in packet tracer. Okay, switches you don't have to do. I mean, switches you do have to type in the mode and then the mode. Okay, just for your information. All right, hope that's been helpful. We'll move on to the demonstration video in packet tracer. All right, everybody, we are back for part 2 of the EtherChannel lecture, and we're going to be doing the example in packet tracer. And in this example, we're going to do between MLS1 and router 1, we're going to have a static EtherChannel bundle. Between MLS1 and MLS2, we're going to have an LACP bundle. Between MLS2 and switch 1, we're going to have a PAGP bundle. Just note that this is going to be a layer 3 EtherChannel. Okay, whereas these two bundles here and here, these two EtherChannels right here are going to be layer 2. Okay, this is going to be a layer 3 link. So keep that in mind. All right, I believe these are all newly configured devices. I should say unconfigured devices. So first thing we need to do, give them a host name. We'll do that real quick. Conft host name R1. Perfect. Oops. All right. So this ether channel right here is going to have 2 links in the bundle. Okay, so we're going to start from router 1, and we're going to connect gig 00 and 01 to MLS1. So we'll start at gig 00, and we'll go to about 1010, and 01 we'll go to 1011. Okay, and right off the bat I get red arrows. Layer 1 is down. Why is that? Well, we know why that is. It's because routers from the factory ship with their interfaces administratively down. So they're in the shutdown state. So interface range gig 00 to 1. We're going to no shut you. Okay. And this is a layer. There's no chance of spanning tree having any kind of looping issues. Why is that? Because these are not layer 2 interfaces. These are layer 3 interfaces. All right. So with that being said, let's get router 1 configured for static ether channel. All right. You got to... This is a really important part to pay attention to because Packet Tracer is a little finicky with how ether channel is set up. In the real world, you wouldn't have to do this. You wouldn't really have to distinguish between whether or not it's a router or a switch or whatever. In Packet Tracer, however, you do have to use kind of an old syntax. So bear with me here because I don't believe I mentioned this in the slideshow video. Okay. For routers, you first have to create the port channel interface. You have to do that first. Okay, you can't bundle the interfaces first. You have to create the port channel first. Remember in the lecture slideshow, you bundle the interfaces together and it automatically creates the port channel. Well, not with routers and Packet Tracer. You have to create the port channel first. So we're going to create it. Interface, port channel 1. Boom, created. All right. So now that it's created, now we can bundle those interfaces together, the physical interfaces. We just created the virtual interface, port channel 1. Now we got to create or bundle the physical interfaces. So interface range gig 00 to 1. And channel group, we'll say 1. Okay. Remember in the lecture slideshow, I did say that routers were finicky with this specific command. Most of the time, you'll be entering the channel group and then the channel group number and then a mode and then, something. However, on a Cisco router, because I should say in a Cisco router in Packet Tracer, it only has static ether channel available on the routers. All you need to do on a router is enter the channel group and then the channel group number. Okay. So now we just put those 2 physical interfaces in static ether channel in channel group 1. All right. Okay. Let's do a do show IP interface brief. We see that we've created our port channel, this virtual interface right here. And really it just consists of these 2 physical interfaces bundled together. What do we need to do on that virtual interface? Well, we do the same thing that we normally would if this was a single link between router 1 and MLS1. We'd give it an IP address. So let's go into port channel configuration mode. We'll just exit interface range configuration mode. Interface PO1. That's short for port channel 1. Or you could just type PO1. Okay. So now we are in port channel 1's configuration mode. Same command that we always do, IP address. Here's what we'll do. Let me label this just to keep track. 192.168.255.0/30. Okay, that's the network of that link. And we'll give this .1, give that .2. Perfect. Go back in here. Now that we know what our IP address is, it is 192.168.255.2 with a subnet mask of 255.255.255. Dot what? /30. What is that? Remember? 252. Okay. I believe router 1 is all taken care of as far as static ether channel is concerned. Let's go to MLS 1. All right. So what interfaces did we say this had? 1010, 1011. Interface range gig 1010 through 11. Channel group. And like I said, even though we use channel group 1 on router 1, we don't necessarily have to use channel group 1 on MLS 1. However, I'm a neat person. You wouldn't believe it if you looked at my desktop, but I'm a pretty neat person when it comes to naming conventions. And when it comes to naming conventions, I like to have my channel group numbers match on both ends of the link. Remember, they don't have to. I can enter channel group 7 here if I wanted to, and it's going to work just fine. But I like my channel groups to match, the numbers to match. All right. Anyway, with that being said, channel group 1. On switches, we do have to type mode and then one of these 5 choices that we talked about in the slideshow. Well, we said that this link, this logical link right here, is going to be static ether channel. So what is our only option to set up static ether channel bundling? It's this right here, on. That's what we want. We want on mode. Look at that. Creating a port channel interface, port channel 1. That's something the router won't do for us when we bundle first. Okay, but on switches, when we bundle first, it creates the port channel. Let's do show IP interface brief. There it is right there. Port channel 1, one of our interfaces. It's a virtual interface, but it's an interface nonetheless. And what do we need to do to that interface? Well, let's get into interface configuration mode for port channel. So interface PO1. All right, now we are in port channel 1's configuration mode. Just think, if this was if this right here was connected to gig 101 and we're configuring gig 101, what would we need to do? Well, there's a couple things we need to do for this one. First thing is port channel 1 is not a switch port. Remember, this is a multi-layer switch. By default, it operates at layer 2. It does not operate at layer 3. You have to tell it to operate at layer 3. How do we tell this logical interface to operate at layer 3? Well, we are in port channel 1's configuration mode right now. We will tell port channel 1 that you are not a switch port, sir or madam. It is a layer 3 port now. And what can we do with a layer 3 port? Well, we can give it an IP address. We should give it an IP address because it says it has an IP address. IP address 192.168.255.1 /30 subnet mask 255.255.255.252. There you have it. I believe that if we tried to ping router 1, we can do it. Ping 192.168.255.2. Look at that. Perfect. This ether channel is set up correctly as a static ether channel. We have a bundled ether channel right here. It's probably a 2 gig connection because we are bundling 2 1 gig links. All right. So now we are going to set up the LACP ether channel between MLS1 and MLS2. Let's do it. Let's pick some interfaces. How about we'll go gig 101 through 104 on MLS1 and gig 101 through 104 on MLS2. We will connect 101 to 101, 102 to 102, 103 to 103, yada, yada, yada. Okay, we are physically connected. Spanning tree is trying to converge trying to figure out between the two switches which one's the root bridge. It's going to take its time because we haven't configured it for rapid spanning tree, so it's going to take about a minute. But we don't have to wait. We can keep going. All right, so we will start with MLS1. conft interface range, and we said 101 through 4. Yeah. Make sure you type gigabit, kids. All right. Interface range gigabit 101 through 4. We are going to do what? Channel group. Channel group what number? Well, we can't use 1. We already used channel group 1 over here. I guess the next logical number would be channel group 2. It doesn't have to be 2. It could be 10. It could be whatever, but let's just go channel group 2. Mode. What mode are we putting it in? Here's our options. Active, auto, desirable, on, or passive. Well, as I said in the last slideshow, I like to put, well, first of all, what protocol were we using? Well, we said in this EtherChannel we're going to use LACP. All right, so that narrows it down between passive and active. These are the only two LACP options. Okay, but as I said in the last video, I prefer to put active on both ends of the link. So anyway, channel group 2 mode active. We have now bundled those 4 physical interfaces into one logical interface called port channel 2. And look, it created port channel 2 for us. To show IP interface brief. There's port channel 1 that we put an IP address on heading down to router 1. Here's port channel 2 with no IP address, as it should not have an IP address. This is a layer 2 link. But just know that the switch recognizes that interface as a interface that we can now configure. All right, exit. Interface PO2, port channel 2. What do we do with port channel 2? What do we always do with a interface connecting to another switch? We make it a trunk, right? Of course we do. Switch port, mode, trunk. Switch port, trunk, trunk, native, VLAN, 777. Switch port, trunk, allowed, VLAN. Well, I'll just say, I don't know, what the heck, 10, 20, and 30. Arbitrary. Not important for this demonstration. Just know that this is a link that an interface that we would configure that kind of stuff. And look at that. We got native VLAN mismatch popping up because MLS2 does not agree with that native VLAN. In addition, MLS2 is not bundled up. Like, it's still trying to use all 4 of its interfaces to send stuff to MLS1. So let's fix that. All right, I think MLS1's taken care of. Let's go to MLS2. Enable. conft. And remember, we said that we are using gig 101 through 104. That should be, well, just trust me. It's what, yeah, there it is. 101 through 104. So interface range gig 101 through 4. We're going to bundle them up. Synchronous logging would be helpful here, yeah. All right. Okay. Next command, channel group. To bundle them up, we use channel group, and MLS2 doesn't have port channel 1 on it, so we could use channel group 1 on MLS2 if we wanted to. But since I'm a tidy network engineer, I'm going to have it match what MLS1 says. So channel group 2 mode, and because we're using LACP for this EtherChannel here, we're going to set it to active mode. And it is going haywire for that native VLAN. We'll fix that right quick. We'll exit out of interface range configuration mode, and we will go into interface PO2, port channel 2's configuration mode. What are we going to do with port channel 2? Same thing we always do, of course. Make it a trunk. Switch port mode, trunk. Switch port, trunk. Native VLAN 777. No more native VLAN mismatch errors. Switch port, trunk, allowed, VLAN 10. I'm pretty sure this was 10, 20, 30. I hope so. All right, and it looks like Spanning Tree is mostly happy with what we've got going on. So let's test something. We'll do show interface PO2 port channel 2. Let's just show some information about that. Look at that bandwidth, 4 million kilobits. It's also known as 4 gigabit. So we now have a nice 4 gigabit link between MLS1 and MLS2. All right, so let's get the final bundle, EtherChannel bundle put together. So we're going to bundle up 2 links between MLS2 and switch 1. So let's connect them. We'll go, let's see what we got from switch 1. Gig 01 and gig 02. All right, so we'll tie into, we will say, how about 11 and 12 on MLS1? Makes a little bit of sense. All right, so on MLS2, we said 11 and 12. Interface range gig 1011 to 12. We are going to put them in channel group. We'll say 3. Mode. Here's our options for the mode. Because we say that this is a PAGP ether channel, what are our options? Well, we've got auto, that's passive, and desirable, which tries to negotiate. So, as I said in the slideshow, I prefer to do desirable or active on both ends of the link. I don't necessarily like doing active and passive or desirable and auto. So in this case, we are going to do desirable on both ends of the link. So the mode is going to be desirable because it is a PAGP ether channel. Okay. Exit out of interface range config. We will go to interface port channel 3. Just remember, we assigned those interfaces to channel group 3, and it created port channel 3 for us. Let's do show IP interface brief. There's port channel 3 that we just created. All right, interface PO3. We are going to make this a trunk. Switch port mode trunk. Switch port trunk native VLAN 777. Switch port trunk allowed VLAN. We'll just say 99. That's the only VLAN allowed along this link. All right. We'll go to switch 1. Enable. CompT. And we will do interface range gig 01 to 2. All right. Synchronous logging. All right. Here's the command that I just entered. Interface range gig 01 to 2. We are going to put that in channel group mode. We'll put it in 3. I mean, like I said, it could be 1. It could be, let's see what it could be. Oh, yeah, sorry. We'll put it in channel group. So on the 2960 switches, it's worth noting that the highest channel group number that you can assign it is 6. You can see I put the question mark here. That gives me, help me out here. What are my options? Well, it tells me my options. Channel group number 1 to 6. That's as high as it goes on the 2960s in Packet Tracer. But on modern Cisco devices, it goes up to 128. Okay, just for your information. All right, let's choose. We'll choose 6. What the heck? All right, channel group 6 mode, and we are going to do desirable because we are a PAGP ether channel link. Ooh, all these syslog messages. Holy crap. Messing up the screen. All right. So let's exit out of here. Kind of go up here a little bit. So last command that we entered was this. Channel group 6 mode desirable. We bundled up those 2 interfaces into channel group 6, and we told it to be a PAGP Ether channel. It created the virtual port channel interface, port channel 6. So let's go into that virtual interface, interface PO6, switch port mode trunk, switch port trunk native VLAN 777, switch port trunk allowed VLAN 99 I think was the VLAN we allowed, and that should do it. Let's test this out. Show interface PO6. Look at that. Bandwidth 2 million kilobits, aka 2 gigabits. Awesome. Okay. And that is it, my friends. We have successfully configured EtherChannel, all three of the different types of EtherChannel with multiple numbers of member interfaces. We did a layer 3 EtherChannel here, and these are both layer 2 right here and right here. And that should give you enough information to complete the assignment. As always, let me know if you have any questions.